Okay, this lesson is about factoring polynomials. We're going to start with factoring binomials. That would be a polynomial with two terms. The most important concept to remember is to look for a greatest common factor being your first step. The greatest common factor, that means that the two terms with coefficients and constants, you have to find the GCF of those numbers. So for instance, for the first problem, we have a 2 and we have an 8. So we need to find the factors of 2, which are 1 times 2, the factors of 8. These are the numbers that multiply to give us those two numbers. What do they have in common? They have 1 and they have 2. Well, the GCF, which is the greatest of those two, is the number 2. Hence the reason GCF is 2. In order to factor this binomial, 2x minus 8, we're going to divide by the GCF. We're also going to make sure that we bring the GCF to the outside because that is a part of the answer. When we divide 2x by 2, we get 1x. When we divide negative 8 by 2, we get negative 4. So our factored form would be 2 parentheses 1x minus 4 parentheses. And in some cases, we don't always put that 1, and that's fine if we don't. We can check this in our calculator. We can put in 0.01, store, the store button, x, enter. When you do that, you have put into place a way to check your problems. Then go back and put in the original problem, which is 2x minus 8. You'll get a decimal number. When you plug in your answer, your decimal answer should match the original problem. If it doesn't, then there's a problem and you need to rework it. Let's try another one that has an x squared. So let's look at number 4. So number 4 is 5x squared minus 60. So we need to know the factors of 5 and the factors of 60. Well, the factors of 5 are 1 and 5. And the factors of 60, there are a bunch of those. We know that 1 times 60 is 60. But we should also know that since 5 is as big as a GCF as we can have, that there's not really any point in listing all the other factors of 60. We could just see if 5 goes into 60. Well, 5 does. 5 goes into 60 12 times. So 5 times 12 is a set of factors for 60. The ones they have in common are 1 and 5. Well, the greatest of those two, well, obviously it's 5. 5 is greater than 1, so our GCF is 5. So we're going to divide this binomial by 5. When we write our answer, we make sure we have our GCF on the outside. 5x squared divided by 5 is 1x squared. We don't have to put the 1. If you like seeing the visual there, it's fine. If not, that's fine too. Negative 60 divided by 5 is negative 12. So our factored form for this binomial is 5 parentheses x squared minus 12. Then if you look down at number 5, it's already been, another one has been done for you. You have found your factors of 18 and 12. So not always is it the leading coefficient, such as like 18, is your GCF. Because 18 is not a factor of 12, but 18 has the factors 1 times 18, and 2 times 9, 3 times 6. 12 has factors of 1 times 12, 2 times 6, and 3 times 4. The most, we've got several commons. We've got 1, 2's are common, 3's are common. Oh, 6's are common. There's a mistake. So 6 is actually the GCF for number 5, that is. So we should be dividing by 6 instead of 3. When we do that, 18 divided by 6 is 3, x squared, and 12 divided by 6 is 2. When we check our answers, these should come out to be equivalent. Okay? All right, so that's factoring binomials. And you can pause the video and try to work out some of the others. Give it a try. We're going to go on to the next page, which is factoring trinomials. Now, this is a little bit different. A little more work involved. So with that said, these are going to look like standard form format. Ax squared plus bx plus c. And what that means is the first term that is in front of the x squared represents a. And the second term represents b. And the third term represents our c. But before we label any of them as a, b, or c, we're going to see if we have a GCF. We've got to do that first. So factoring is all about finding the greatest common factor first. So this time I've got to find the factors of three numbers. Well, those three numbers would be 3, 27, and 60. But here's the key. The lowest number that you have is going to be the highest number that you could possibly get out of all three. So does 3 go into 27 evenly for a set of factors? Yes, it does, because 27 divided by 3 is 9 evenly. In the same case for 60 as well. 60 divided by 3 is 20. So our GCF for 3, 27, and 60 is 3. So we're going to take this whole trinomial and we're going to divide it by 3. We're breaking it down, we're getting it smaller so we can find the factors. So we bring our GCF to the outside. 3x squared divided by 3 is x squared. 27 divided by 3 is 9. And 60 divided by 3 is 20. Oh, I left off my x. Put our x there. So now I've got this new reduced trinomial. Here is where we use a is our invisible 1, b is 9, and c is 20. So we can say a is equal to 1, b is equal to 9, and c is equal to 20. And the reason why we use that is so that when we set up a table, we're going to take a times c, which means 1 times 20. Well, that's equal to 20. So we need all the factors of 20. All right, so we need factors of 20. 1 times 20 is 20. 2 times 10, board X up. 2 times 10 is 20. 3 doesn't go into 20, but 4 goes into 20. 4 times 5 is 20. 6 doesn't. 7 doesn't. And that's all of our factors right there. What we want is the factors of 20 that total up, add up to be the middle term, 9. Whoops, 9. Well, 1 plus 20 is 21. 2 plus 10 is 12. 4 plus 5 is 9. Ah, there's our magical set. That is our set of factors that satisfy adding up to be 9. So two numbers that multiply to give me 20, but add together give me 9, is 4 and 5. So I'm going to take this 4 and this 5, and I'm going to make a binomial, two binomials. But I'm also going to bring down my GCF. So we just bring over our factors, and there it is. That is our factored form for this trinomial. And we can check this the same way that we checked the binomials. We can put in 0.01 store x into our graphing calculator. We can plug in our original problem here, right here. And we can also then put in our answer. And they should be having matching decimal answers. Okay. So there's an example 2 there, and here's an example 3. Example 4 has been done. Let's look at example 4 also. So here's example 4. Example 4 right here. X squared plus 3x minus 18. So this one's a little trickier because we have a negative in there, or a minus sign. Well, when we check for GCF, we're checking to see what is the greatest common factor of these items here, these numbers here. So what's the GCF of 1, 3, and negative 18? Well, anything with a 1 can't be any greater than 1. So our GCF is 1. So you're really kind of skipping the first step because you don't need to divide x squared plus 3x minus 18 by 1 because it's going to give you the same thing, x squared plus 3x minus 18. So we're going to go to the next step. We're going to say, what is a times c? Well, a is 1, b is 3, and c is negative 18. So if you see right here in our table, the factors of negative 18 are listed. They've already been listed out for you. So you've got to have factors that when they're multiplied together, you get negative 18. But when they're added together, we're looking for the b. We're looking for the 3. So we add up our factors, and you see our list right here of factors that have been added up. And our set that we are looking for is negative 3 times 6. Well, negative 3 times 6 is negative 18. But when negative 3 is added to 6, we get positive 3, which is the same 3 that we're looking for in the center of our trinomial right here. So what it turns out to be, our factors would be x minus 3, because the minus comes from our negative, x plus 6, which comes from the positive 6 in our factors. And that, my friends and folks, is how we factor trinomials.